Hello all, and welcome to the 9th webinar in 12D's training webinar series. My name is Lisa Stewart, and I'm the Marketing and Communications Coordinator at 12D Solutions. While we wait for everyone to finish joining and get comfortable, I'll launch a polling question. You'll have about 30 seconds to answer about whether you use the element, fixed and floating part of the superalignment in 12D model, and if so, whether you utilize the computator referencing features. And then I'll show the results. Okay, looks like we've got a fairly even mix of attendees here today, so I'm sure we'll all get a lot out of the webinar. Our 12D training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D model software. The aim of these webinars is to upskill 12D model users and broaden their understanding of the capabilities of 12D model. We'll keep running these webinars regularly and recording them for posting through our website and YouTube. The first 8 webinars from this training series, as well as the first 13 webinars from our Industry Solutions series, are available online if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenter for his insights if there's time. Today's webinar, Superalignment's Element Method, will be presented by Peter Tainton, who has over 20 years' experience in various facets of road design. He's been engaged in large projects for several major councils and government road authorities. Over the last 15 years, he has worked closely with our programmers in the implementation of a variety of design features within 12D model. These include the superalignment and design speed tables, construction subgrade detailing, design geometry components, overlays, pad design interface, and visualization. This webinar from the training series will look at going beyond the traditional IP design within 12D. Peter will discuss the use of fixed, floating, and free as they relate to lines, arcs, and transitions. Examples will be read in from 12D's library and edited, and explanations will be provided on the variety of each element type. The element method will then be extended to include referenced computators. This is the goal, where your design layout is linked together and any changes quickly reflected throughout. Over to you, Peter.
Welcome to our presentation. Traditionally within 12D, alignments were done using the IP method. The addition of the superalignment enriched the IP options with a variety of commands. Change of grades, tangent wizards, etc. Even though the IP could satisfy most situations, there were obvious things that it could not just do. Hence the implementation of the element method. This resulted in alignment designs could take into account horizontal constraints, such as offsets from straights, like property boundaries, offsets from arcs that could have passed through an existing road centerline, arcs that pass through a point, where the radius is unknown, compound and reverse curves, 2-centered and 3-centered curves, straights and arcs that could extend through a point or at a set distance from the previous geometry part. In the more advanced road and rail design element method, arc-to-arc and back-to-back transitions between arcs and straights were expanded. Vertical constraints could also be met with the use of apex parabolas, fixed parabolas passing through 3 points, parabolas through a known point where the radius is calculated, and there is much more, and all possible due to the underlying solving method called fixed, free and floating. Fixed parts are set in geometry and are not dependent on any other element in order to solve. Those things would be things like fixed lines. They can be defined by 2 coordinate points or a coordinate point and a directional bearing. A fixed arc. So the arc can have the center, ends and radius values set. It can also pass through 3 points and also have a start point, radius and a direction. But they are fixed in space and, as said before, are dependent on no other element. Free parts are positioned between 2 solved parts, whether they are lines or arcs, and are solely dependent on those 2 parts in order to solve. So a free arc can be defined by a user-defined radius, And when we go through this process, you'll notice that our signs for radiuses are important. Clockwise is positive, anti-clockwise is negative. The free arc can also pass through a point where the radius is calculated. You can specify a length, and again the radius is calculated. It can also extend from the end of either part, the first part or the second part. A free line has no specific data like the arc, but just generally fits between two arcs. Free transitions also obey the same rules as the arc when they are dependent on the two solved paths either side. So transitions can be a length that is calculated, an arc to arc where a start length may be specified and a second calculated, back to back, etc. Floating elements depend on only one solved part, as they have additional information within their definition. A floating line can be set up through a point, can specify a direction, or can go from the end of a previous element at a certain distance, taking into account the instantaneous bearing at that point. Floating arcs can be defined by point and radius, direction, 2 points. They can be from the adjacent part or end of the adjacent part and pass through a point. It can also go from adjacent part with a radius and a certain length. And again, it can also be at a radius through a swept angle. Floating transitions can be defined again by transitions arc to arc and also back to back. So to start with our job, we'll just look at some of the simple components or elements for a alignment string. So again, we'll set up our label here, and we'll just pick up our design left hand side and we'll go create. So in this subdivision project here, we're going to look at the alignment string down this road here. So we're going to look at the property boundary by 2 points with an offset, the property boundary down here, and look at the types of free arcs, or in this case similar to fillets, that would be available. So we insert the part, it's a line, 2 points. So we can pick the points one at a time, but we also can use the same as button to pick a boundary if we wish. So I'll select the 2 points I'm interested in, and I go set. So you can see that the solution comes up. You can see all the labelling, which is a indication that the alignment string has solved, and we also want to introduce our offset. So we're going to look at a 10 meter offset. We go set. So obviously the offset is positive to the right and negative to the left, similar to what the arcs would be. So again, we're going to insert another line. This line is also fixed, but we'll use point and direction. So in that case here we can go same as, pick this boundary here with direction, go set. You'll see it finds the point in the direction of that boundary line, finds the intersection point. In this case here, our offset would be -10. Again, we can alter the points, the direction, and more importantly the offset on these lines. So we now look at the arc between. So again, the free arc depends on these two elements. So we go and insert between that part, and we select under arc free. So we'll look at the through point one first. So the point I'm going to get, I'm going to use my Snaps CAD, go down to point, and pick midpoint. So I pick that point there across the other side of the road, and I go set. So it's now taken that point, and then with the assistance of the two elements either side is able to calculate the radius value through that point. So it's always a good idea to use that to if you want to pass through a point, to find out what the radius is. And if you decide that the radius needs to be rounded off, you simply then just change the element that you've already got to radius, and again it'd be a negative. So let's go to the left hand side and we go set. As I said in the intro, is that the free arc is dependent on these two solved elements. So in that case, if I decide I don't want to use the element, and I go set, right, then the free arc will fail, And again, a good indication that your alignment string is failing, besides the word error here, is that all the labelling disappears. So again, I can turn that back on, and I can go set. There's a difference between using and not seeing one. So in case this is visible, still uses the element, but then you just decide that you don't want to see that part, and the curve will stop here. So again, the type of parts for the free that are available. Again, we're looking at lengths. So if you're interested in just the actual length of the arc, then 12D will then calculate the radius for you. So if I say the length of the arc is 150, then it will turn and calculate the radius to minus 92. Again, there's also a free arc option, and this one here is from end. So basically, it uses this the attach to option. You'll see that quite a lot through the element parts. That means it's attaching to the previous line. So the end of the previous line becomes the tangent point. So if I change that to attach to next element, then it would attach to this tangent point where that fixed line is. So again, that's basically what the fillets or the free arcs are like. So they're simply just a filleting through between two fixed elements. And again, we're just doing lines, but these also could be any solved part of your alignment string, could be fixed curves. As long as those two parts are solved, the free arc will utilize those two parts. So we go back to our arc here, and we decide we don't want to use the line. We'll probably just delete the line totally. And we go to the arc here. So instead of the free type arc, we're going to look at arcs that are floating. So again, we've got a point and radius. So again, we can select a point, and we can use our Snaps CAD like we did with the free arc. Select midpoint. Go set. And the radius here, we're minus 100. Set. So in that case here, we've got the floating up. You notice it does not need an extra element part, because we specified not only the radius of the arc, but also a point that we're passing through. So there's enough geometry here to be able to create that arc. Again, the floating arcs, you've got point direction 2 points, for instance. So you can pick 2 points. Those 2 points possibly may be construction points. They may be just points on an existing road surface of some sort. You go set. So again, that's enough information to create the arc along with the previous element here. So you got arc from end through a point. So in that case, it would just go from the end of the alignment string. So if we go and pick another from end through point, and I pick a point here, go set, it'll then create from the last point here through that point. So, and if you did adjust this point further down the road, right, then this arc would adjust. So again, we're looking at the from end, radius, and length. So we go from the end of the straight. So we go say a minus 100, and I want to go for a length of 100. I go set. So you can use some of these parts that are highlighted as squares or circles and that sort of stuff. They're high level points. So you can actually then move those points. So I can move this point down to here, and the floating arc attached to that will move because it's attached to this point here. So again, I can go back into my floating arcs. One of the last ones I have here is a from end, radius, and sweep. Good for doing traffic islands. So here's my radius might be 2, and my sweep angle would be 90 degrees. It's going to attach to the previous element, and I go set. So again, if I was doing a traffic island, I might want to go around 180 degrees. So I can change that to 180, a set, and it sweeps around like that for me. So that's the type of elements or floating arcs that you have, and just in the basic situation. So as long as you recognise for the free parts, they do need the 2 solved parts either side, but the floating part only needs one. In this case, you've only got one line, but so we're using the attached previous. But if you had another line here, you could have attached your floating arc to the next part in the geometry. We'll now look at the tie-in part of our design. Here we've got an existing road. We're going to look at an overlay and reconstruction type job, and so inside that reconstruction type job, we're going to be looking at the matching into the existing road surface. So we have some points here that represent a survey and a curve that's been picked up. We're then going to float a line through to define our approach bearing. We're going to put a radius construction in here, a free radius for our deviation or reconstruction area. We're then going to tie it back into the existing along a curve and back onto a straight. So now element part, go to horizontal, and we're going to select arc fixed. We're going to go 3 points. So it's going to pick these 3 points. And there's just 3 points on the survey, points that you can generally move around and adjust, but points that you would think would represent the curve. Again, being a fixed element, it's able to be solved on its own. So if you did finish your alignment string, then that would be your alignment. So now I want to adjust my bearings so that I'm along and pass through this point here. So I go and insert another point, and that's just going to be a line through a point. The point I want to pass through is that point there. So now building up my alignment string over the existing alignment. I want to put a free arc in here for the deviation, but I'm going to go back onto my 2 points along my straight, and again insert another fixed line. So I picked the 2 points up, picked that point, and the second point. So again, it solves because it now finds the intersection of the solved floating line here and the 2 fixed lines there. So if I go back and insert my reconstruction area, and I want a free arc and a radius. So put in our minus 280. Now I want to be able to tie into the existing surface here and basically replicate the curved geometry that may have been used on this existing road. So in that case here, it could have been a combination of an arc. It could have been an older road which used a radius with some transitions, but it's a bit hard to know. So in this case here, I can just go to the fixed line, and I can insert and put another fixed arc in, similar to the start, and I can pick 3 points. So I looked at these 3 points and defined that they would be the best representation of the arc. I go set. So you see that the alignment string isn't solving anymore. There's no text or anything, and there's a big words with error through the middle. So this is a solved or fixed part of the alignment string. This is a fixed part of the alignment string and solved. We need to put something in between here. So as I said, traditionally it may have been a transitional curve. So we can also then go into here and put in a transition free and go set. So just like our arc fillets, we're able to then put a free transition. It's then calculated by the position of these 2 fixed elements, and the length is 50.954. So I go to the end of the job, and again I can finish off on the fixed part of the road. Just going to pick 2 points. So I think that represents the one of the straights. I'm going to pick a point here and pick a second point. So similar to the other one, we're going to say that there would probably be a transitional curve in this older environment. So we're just going to insert and then put in a transition and go set. So that gives me an idea of what the horizontal may have looked like. So again, we're tying into the existing, matching the existing curve here, worked out some transitions or to suit, and we're now going to look at some of the vertical. So we look at our vertical geometry. And again, we're going to try and tie into the existing and come up with some information that would suit our existing or our overlay area and also our reconstruction area. So the first thing we're going to do is to match the crest here. So we're looking at a parabola. We're just going to pick up 3 points. So we're just snapping onto points on the tin surface that represent the crest here. We go set. So now looking at the areas that we're going to tie in, and again you can these parts can be out of order. I can go down here and do this bit, then do this bit, and then join the bits in the middle with the appropriate elements in relation to either free or floating. But I'm just going to work my way down the alignment string. So now I want to put a matching grade on this part of the road. So I'm just going to put in a fixed line. So again, I just pick up the line, 2 points. So now it's talking about change height points rather than X, Y in the horizontal. Right, so again, these two points are that we need something in between here for the actual solution. So we'd like to probably, the line actually passes through here and this grade comes down here, so we'd probably like to put something like some sort of parabola in here, but we're going to look at a compound or reverse parabola. So we go back in here, and those are the free parabolas. It's going between 2 fixed parts, and we're going to pick up a compound. So the compound just allows you to say I want 50% of the curve on the leading curve, go set, and it then goes and puts in 2 reverse parabolas for you. So in the area where I want to finish off, I've been using fixed in this part here. I snapped onto the tin surface for 2 points. But there also is a computator. Now, this is the first one we're going to look at a computator, but as I use computators throughout the job, throughout this session, all they are is just basically a little bit more advanced parts, but they still have the same solution method of fixed and floating, but they're referenced to something. So in this case here, we're going to go down to a computator, and we're going to pick fixed points. And that means it's going to be able to drape onto a tin surface, the existing survey. So I'm going to use drape EX, which is partial drape. I'm going to pick up the existing and go set. So it's actually draped all the way along here. I only want this last little bit, so you can control that by the start and end points. So here I'm going to go to the end point of my alignment. I'm going to come back minus 100 for an extension. And what that does then, it actually then sets up the draped geometry here. You can see all the points where it crosses the triangle, and then basically sets up the end of the geometry. So if we go back to my fixed line here, I now want to be able to put in a bit of geometry between here, just like the horizontal. It's going to be between 2 solved parts. It's going to be a free parabola. So if we go insert, and the part I want is a parabola free. Again, there's all different sorts. We'll just have a look at a few of them. So you're looking at passing through a point, and I go set. So it passes through that point, calculates what the length and radius of that parabola is. So there's the information panel here. So I can bring up the information panel, and go down to the parabola part, hover over here, and you see that the radius is 2419.592. So somebody does want an exact radius for that. You can, as I said before, you've used the point to calculate it. Now you can just simply go down to parabola, grab radius, and you say I want a 2400 radius. The types of free parabolas available there: radius, k value, maximum length, which means it will turn around and just find the nearest point of this point to that point, and then fit in the appropriate maximum length parabola. But you also can then go down to even an asymmetric one. We've already used the compound one. The asymmetric just be a combination of one length versus another length. So just they can be used just to sort of try and marry down to match what you're trying to achieve. So again, we go back into our fixed parabola at the top, If we use their information panel, we might find that radius there is quite small, so we want to do a bit of further reconstruction and drop down that crest there. So again, we can just replace this fixed parabola through the 3 survey points. We can now replace that with a parabola and the apex and radius. We can select our point for the crest, and we can say our radius is minus 1800. We want to say minus 50 before and minus 50 after. They're just the construction lengths for the projection of the parabolic curve. And I go set. Notice that the radius here was a negative for crests, where down here was 2400 for the sag. So here we're able to then go and set that up. So again, we can all take into account not only the point of having these as control points, we can use the move command here for any of those high level points, and we can move them back and forwards like so. If we wanted to control this area here by grade rather than just 2 points on the ground surface, we could go to that fixed line, and again we could change it from a fixed line to a point and grade. Again, we could pick a point on our surface there. Let's say our grade would be minus 7%, and we can say minus 10 and 10 and go set. So then we're able to keep the point where it is and then manipulate the grade to suit our vertical geometry. So that gives you an idea of the variety of the element parts, being able to put in crests, passing through 3 known points, and then also matching into existing, draping onto a tin surface, all part of the fixed and floating, and then into the computator reference type geometry. So now look at back to our urban type development. So if we looked at the fixed and floating, or the free one we did for the main road, we would also then adopt that for our curb return. So in that case here we're going to our curb return geometry. Again, we're going to pick up our curb returns. Look at our labeling. Create. Right, so if we looked at did our curb return in the way that our main road geometry had been done, and if you're fairly new to the fixed and floating idea, you'd then come into here and you would go and set up in the horizontal, you'd insert that, and you'd have a fixed line, but we're going to drop down now and do the same process, but we're going to use computators. So in other words, it's the same idea, same underlying fixed and floating solving, but we're going to reference something rather than just picking 2 points that in space. So we're going to turn around and say we've got a fixed line, set. So we want the reference, so we just want reference on here. We're going to pick up a name part. So in this creation of this centerline, we were able to name the part. So as I'm creating all these parts, we've given that a particular name. So rather than having to refer to a segment number or a point, we're able to do a name part. So the name part, I can get a center mouse button, snap onto that. We can then also say I want to be minus 3.5 off that road, which sets up my lip of curb line. Again, I can then copy these and paste. If you paste something down, you just got to highlight it and turn it on. So I drop down the line. I want to now pick this line here, which is this other road. So I pick the direction. Okay, the name part again. I can pick that straight. It's called line 10, and the offset is minus 5. I go set. So just like we did before, I've got to come back in. I've got 2 solved parts now, so I can then come into here and insert an arc, free radius, and I can say it's a minus 15 or minus 12, wherever it may want to be. So again, you've got the option to come back into these parts here and then make them invisible. You can't turn them off, remember, because otherwise the arc won't solve. So I make those two invisible, and I've got that sort of process going. So it does, does create the picking, but obviously the reference to these rows, of these rows changed, the curve return will resolve. You also got control over the offset. But that was, we had to create 3 parts to create that. So rather than having to do that all the time, we're going to be able to go and grab a different type of one. It'll be a computator. In this case here, it's going to be it's been specifically set up for typical things like curve returns and so forth. And we're going to grab a fixed compound. So under the fixed compound, we're going to look at a fillet. But you'll notice there's also quite a lot of other things that we can do here. We're just going to pick fillet. We want to be able to go between this segment, that segment there. So we're going to turn around and say we want to do fixed segment to fixed segment. What's our radius? -12. And I go set. Make sure you go set on those as you work your way down through those parts. Once you pick your option here, it'll change to whatever the type you have to pick. I'm going to pick segment. So again, I want name part because I've named these other parts on the road. So I go accept, and I go the name part, and my offset again is -5. I go set. So it puts in a construction line there for me. I drop down to the next segment. Again, same process. Name part. I pick that with direction. Send a mouse button to grab the name part, and my offset is -3.5. So in that case, now we've got the fixed compound, but all 3 parts have now been combined into one. So instead of having to do 3, you now everything is collated in here: the pick of the segment, the offset, the radius arc, and so forth. So the fixed compound is the sort of one, the element or computator that we will use quite a bit. We're going to look at the vertical geometry of this curve return now. So now vertical, have a quick look. So again, it's got we'd like to reference it to our road center line, so we're going to use a computator. We're just going to look at a fixed line. So the fixed line option we're going to ask for here is a change in reference. So it picks the reference alignment, and the change type it talks about here is referring to your curve return. So in that case here, it's easy for me just to use vertex. I've only got 2 vertices on this string. The slope type is a crossfall from the through road. It's going to be -3%. And what I see in the vertical geometry side, I wouldn't mind seeing it's over -5% geometry at the start, and I want it to be 0 at the tangent point. So again, I've got another one here. I'll just create the 2 parts here before we go and have a look at our section view. So we go copy and paste again. Whenever you do that, turn it on, go set, and then go through and pick the other strings. This one, I want this one here. Again, that'll be vertex number 2. Typed, and I want to say here I want to go from 0, and I want to go see a bit more geometry 5 meters past the curve return, the tangent point. Go set. If we go look at my profile here, and we profile that curve return, we've now got this geometry. We obviously that's just a straight change of grade. We need to put in some sort of nice curving in between, so we're going to do a compound parabola. So again, it's a free parabola, and it's called compound. I've looked at a few of these before. So this is a 50%, and I go set. So it just basically divides up the space and then puts into reverse parabolas to suit your geometry. So it's locked into your through road at the -3% here, and instantaneous grade, and the same here, and it's just done that for you. There's no real control over what happens in the middle part here. So in our job, the crossfall between this center of the road here and across to here is whatever it ends up being. So if you want a bit of control over that crossfall, we can create an alignment string, super alignment for that, and then use some of the element parts to lock that into our design here. So we'll grab that one here and we'll just call that one X01 for crossfall. And we'll put it onto a model called curb return crossfall. Again, the label, we'll just use curb returns. We'll go create. So what we're going to do here is create basically a construction alignment, not something that you would issue out in the process of the job. We go to horizontal. We're just going to pick a computator, and it's a fixed line. It's only one element, and the fixed line is 2 points. And the 2 points are simply the reference type. So it's going to be a name part again, and we're going to pick the end of this alignment string here. Then we're going to go center mouse button, grab the alignment string, it will return the start point of that line. This is the syntax for the name part. And we go set. So it puts a little square there, that's the end of that point. Second point I want is somewhere out here. So the best idea is to just go reference, pick segment center, vertex, and we're going to grab this guy here. So it just simply puts in 2 points bisected through here. That's going to give us an idea. We can put some vertical geometry on this. It's going to be able to go from the level of this string here at whatever crossfall we want, minus 2% for instance. So again, we're now vertical. We're going to have to put in one grade and a point. So again, we want to lock into this road here, so we're going to use a computator rather than just a Chinese 0 and a height. We're going to grab fixed line. So the fixed line, the one is point and grade. So we don't care about the start point. 50 meters is fine. The point we want to do, we're going to use a cut through string. So the cut through string is this one here. We get set. And the grade is minus 2%. So I go to my section view and I profile this crossfall construction string. You'll see that it's locked into the road centerline and it's got minus 2% grade. So if we go and profile our curb return and we have that string added in, you'll then see this is the point of that cut through string, or that across the intersection at minus 2%. So I now like this, my geometry and my curb return, to actually pass through here. Okay, so it's just a matter of picking up that point and possibly specifying a grade. So that point here, I go to here, in the vertical, I go past that, and I'd insert another part. And that part again is going to be a computator, and I want to put in a fixed grade there. I go set. So we're just going to do point and grade. So we want an instantaneous point here, and so that I can of 0 length, so I can just alter the grade whenever I want. So I can put in here 0 and 0 as the construction lengths, which will then effectively just give me a point. So the fixed point again is my cut through string, just like it did in the horizontal. And my grade, let's say, might say minus 6%. Now we look at the free compound here. Right, it is now linked to the intersection point here. So all we need to do is put another free compound in here to smooth out this change of grade here. So again, we can just go copy, pick that, go paste, turn it on, and go set. So now our curb return is not only locked into the crossfall and the instantaneous grade to the center line at the start and end, but also a point crossing at the crossfall across the road. We can adjust that crossfall again each time and then resolve the alignment string. So I go back to here, I can look at my vertical, and I can say my grade here might be minus 1.5. So I go set. And the point will jump up to there. So again, a solution here. Then passes through that point. So again, just a way to be able to utilize those simple geometries. They're only just fixed between 2 points, fixed a point and a grade, and just a quite versatile compound parabola. which just does either reversed or compound or back to back depending on the changes in grade. We can then go up to our with that fixed compound, and again we can continue that through onto a cul-de-sac. Again, we look at our label. Just pick this one nice simple one, just shows the radii. Again, just like the Kubernetes before, it's a computator and fixed compound. So the fixed compound here is not going to be a fillet, it's going to be a cul-de-sac. So the cul-de-sac has lots of options here preset, we'll just leave it to that. So we'll get set, and then we'll drop down and pick our string. So we don't want to pick 2 points, we just go reference, which allows us just to pick with direction, and then creates the cul-de-sac at the end of the alignment string. We wish to drag this back, so back on our fixed compound here, we have a projection, so we can say -9 to drag that back, and drag back our cul-de-sac to that point there. Has options here, you can actually put in little tangents in between there, so I can say 5 meters on the left and 5 meters on the right. And obviously you've got adjustments on the left and right. So prior to these sorts of element and the fixed compound, you would have had to do 1, 2, 3, 4, 5, 6, 7 type parts to build up the cul-de-sac, and at the moment the fixed compound does it all in one go. If we look at our other types of everyday geometry, not only curb returns but cul-de-sacs, is also things like the right turn lane. So in this case here I might put a right turn, and we'll put it onto our island. So the right turn lane, we're going to look at a position here at the tangent point. We then want to be able to go a certain distance, be able to put in a fairly reasonable taper with some 2 radii in it, and also then introduce offsets from the road centre line for the right turn lane. Fair few parts, but the taper option is combined all in one, like the fixed compound we've already seen. So here I'm just going to put in a fixed line. We're going to select 2 points. So I pick my 2 point on the tangent point there, and we're going to select another point on the straight, somewhere about there. Like I said. Right, so we go back and look at the next part. Next part's going to be a start from this point here. That'll be the nose of the island. It's going to have an offset, and it's going to have a directional line with some sort of distance for the deceleration length here. So if I insert that, again we're going to look at a fixed line. We're going to use point and direction. So we can use the same as button. We pick our alignment string with direction that we're travelling for our alignment. We're going to pick a point, so rather than the point where I drop my cursor, I'm going to pick that nose point that I've utilised. I want to be able to say the relative distance, so say -50 is the deceleration length, and I don't want to go any further past that nose point, so the relative end is 0. So and my offset here is 3.5. So again, I pick the direction this way, so that's the offset to the right hand side. So these 2 lines are parallel, so we need to have another part that will form the taper. So again, we go back to here, insert, and the one we want is a transition compound, and we pick up compound taper. Right, so it asks you for a taper length, say 35. So we're going to go from here at a radius along a straight, then back on a radius again. So the approach radius here will be clockwise, so it'll be 50, and the departing radius will be a -50. We're going to attach to the previous last point, this point here. So we go set, and then creates the part for you. So we can look at the different styles again that are available, the labelling styles. We might grab the this one here, which shows you a bit more information about the tangent points and a little bit easier to see. So go back into our horizontal. So look at our free compound. At the moment it's attached to this point here. So I did put in a point here, a distance that was supposed to be my deceleration lane. So I'd probably like to start the taper at this point rather than at this point here, rather than that point. So it's just a matter of changing this and saying attached to the next element, which is this point here. So I change it to next and I go set. Still not quite right. The deceleration length is still not the 50 I was after, because the taper itself has an option to say the 35 meters I've specified, do you want to go from the center of this arc to the center of that arc, or the actual IP point, or do you want that to be the full length of the taper? I want it to be the full length of the taper. So when I go set, the taper then goes from the taper length is defined from the tangent point here to the tangent point there. So down the other end, I want to be able to come back around for the nose of the island and then project up the road this way. So again, as we showed before, you can go insert and there's a nice floating option. So I can turn around and say radius from end and sweep. So I'll say that the radius is 1 and I want to go 180 degrees. So I want to go back on itself. I go set. It then attaches to the previous element and does the nose for me. If I want to finish off along the straight here, roughly to where this island started, I can then go insert. Again, it's just a matter of inserting the different things. I can end in a floating line, so I can simply just go floating line through point, and so if I had a point there, I could do that, or I probably in this case here we just might use floating line from end, which allows me a distance. So I can turn around and say it might be 95 meters, attach to the previous again, and I go set. So it then creates my alignment string. Again, all those particular features, I was picking just points, so they're not referenced to anything. It doesn't know about this tangent point, and this point doesn't know about the intersection here. But with the computators, there is an easy way to be able to adjust that. So instead of doing the fixed line here and just picking two arbitrary points, we can get into the computator and say fixed line again. And again, we can say we want 2 points. And the 2 points I want, in this case here, I've got a name part, so I can select the tangent point. The name part, I pick the curve, and I go set. So now it's created a point that is actually locked into another alignment string. It knows about that tangent point. So the second point can be exactly the same thing. I can go name part, pick that, center mouse button, grab the name part. I want to go an extension backwards, so I want to say I want to go minus 25 meters. That then creates the straight for me, but it's actually linked to this tangent point. So this curve does change or adjusts, my alignment string will adjust for it. Same for the fixed line here. So that fixed line there, I need to be able to adjust to a point that may be an intersection from here at this particular bearing. So again, I can change it from a normal fixed line to a computator. Again, it picks up the same idea, same picking process. It's just that you're picking things that are referenced. So in that case here, I'll turn around and I'll say I want point and bearing. So again, the relative start will be minus 50, and the end will be 0. So the fixed point. So in that case here, I want to be able to go from the reference point here. So I'm picking up reference. So the point I want is a name part, or cut through. The cut through string. That one. The string I want to cut through is that. Get set. It creates that point. By picking the reference alignment and the string that it cuts, I can now move backwards along the reference alignment using the extension. So if I turn around and say I want to go 15 meters along, I can go set and it creates that point for me. I can also then say I've got that point, I now want an offset. So I can say 3.5 for the offset, and in that case here it's a minus 3.5 because it's working along the reference alignment. I go set, and last of all I want a bearing. Again, I can go reference bearing. I can pick this alignment string here. So now not only have I locked in my right hand turn lane, but I've locked it in at the start here and also as an offset distance from the centre line. So if I do some vehicle paths and things like that, I can adjust the nose of the island back and forwards by simply going to my extension here. So I can change that to 20, go set, and it then drags the nose of the island back. I can even finish the island itself by locking onto another known string again, and it's the same process. It's still a floating line, but it's a commutator. So I drop down to floating line. The type of floating line I want is a floating by point. So I can create that point. So I can turn around and go set. And the fixed point I want. Again, if I look at the reference and I pick up cut through string again. So again, your reference string is your alignment string you're on. I'll go to name part, sorry. And I pick the point. I go set. You see it's going the wrong way, but I forgot to put in my offset. So in that case here I've got 5.5. I've got to take into account the offset of the lane and also the width of the island. So now I've got my whole job is locked into that alignment string. So again, I've been looking at the referencing and those sorts of things. So if we finish our job here and we do edit this alignment string, for instance, and we go into the horizontal part, and we're looking at this arc here, we could change that arc to a 1000 radius. So therefore the tangent point is now right back here. So again, because our traffic island is linked at the start and the end to this point, I can simply just go to resolve alignment string and resolve my alignment. So there's lots of simple geometry. That one there was the same process, but instead of you picking points that were just static points, we're actually picking name parts and being able to access the tangent point of that curve and also an offset distance where that string cuts your center line by having an extension that then represents the clearance at the intersection. So if we finally look at another simple type of geometry, and as you do look at this geometry, try and think of how long it would take to do normally in a by IP method or even the CAD process, and any changes that may have happened. Let's go into label, create. Before we start, this is again another super alignment, reference to this road, reference to that road, just as fixed lines. But it does have a little special one here. So in this case here in the horizontal, the first fixed line allows you to pick a point. So it picks this point here and then allows you to do an angle in relation to your reference line. So you can specify 110 degrees to the direction of your reference alignment. Which then ends up allowing a 70-degree high entry angle here, typical of these types of intersections. The rest is just simply reference to segments that we've done before. Each one of those straights were named side 1, 2 and 3. So we'll be able to use the name part in referencing our alignment string for our traffic island. In that case here we're going to go down to a commutator again. We're going to go fixed compound. Similar to the curb return we did before, but we're now talking about a traffic island. So we drop down to here and we're going to fillet. So we're going to look at a segment. And what's our radius? 1. And we go set. So it's simply a matter of just picking name part, selecting the name part, side 1. Offset will be 1.2, Again I go set. Pick the segment again. Send a mouse button to pick it, and this time the offset again will be 1.2. Okay, so we've got our fillet, our little nose of our island already started. So we can copy these down, so we just go copy, then paste. Again, when you do that, turn it on, go set. We'll drop down to the next one. This time the radius here is 0.3. And the segment we're going to pick this time is this guy, the name part. And our offset is 0 in this case. The next part I want to pick is that one with direction. I'm picking clockwise with all this. Send a mouse button to pick the name part, and my offset is 1.2. I set. Then puts in those two parts. So obviously they're two fixed or solved parts, or two fixed arcs. So to join the two, we just simply go and insert a free line. Again, we can copy and paste. Turn it on, and then go through and pick the previous elements. So again, this time the curvature is going to, the island's going to be 0.6. We're going to pick the direction on that one. The offset here is 0. We'll leave that defaulted. Pick the final segment, which is again this one here, and the name part. And the offset, there's our traffic island. So we're missing these two connector parts. So again, it's just a free line, so I can go insert, copy, put it down there and go paste. And last of all, I can finish off with one. Go paste again, turned on, set, and then finish. So the only reason that the alignment string hasn't solved in this case here is it needs to be told to be closed. So we just pick the closure option under properties, and we go set. So most traffic islands and those sorts of things, you normally have a road design service that or tin that you've created, and you're just draping these on top. So in that case, for the vertical, we go to the vertical part, and like we did in our tie-in job or our reconstruction, we drop down to computators and we pick fixed points. It's just a matter of draping onto a tin. The tin I want to drape onto is design. I go set. So if you look at your vertical geometry for our island, it's just got vertical geometries that match the design tin surface. So again, you look at the simple geometry. We haven't picked. We've reused quite a few little parts. Not anything altogether difficult. We're able to reference things rather than when we first started by just picking 2 points on a boundary. We're able to reference something and put an offset. So if any changes to those reference things, then now we can just go and resolve, either resolving manually or through a chain to update our alignment strings. Last of all, is just what I refer to as a free form design. So in that case here, we're just going to create a alignment string. We'll just call it path, and put it onto a construction alignment. So what we've got here is an existing path finishing here. We've got some trees and so forth to which to meander our path through. We've got a retaining wall here, circular retaining wall, rotunda. We need to be 3 meters offset from that as part of our geometry, meander through the trees, and finish off 10 meter away from the building line. So again, it's just a combination of a couple of different parts. In this case here, is a fixed, floating, free, and back to fixed again. So we'll go into the label option, and we'll just set this up. Also drop down to, even though we're trying to match into an existing footpath, just so we've got a bit of thickness and looks interesting, we'll drop down here and we'll go and set this to a culvert, and the width is 2 meters, and the height will be the Don't worry about too many levels, but we could turn around and say obfet. So basically we go to the horizontal, and it's just a matter of simply just starting. So we're going to say, look, I want to be able to reference, or you don't necessarily have to reference this with Computate because there's something that's built out in the field. It exists, so it's not going to move it at any time. So we just simply just go fixed arc, use the same as button, zoom in here, pick the direction, pick up that center line and go set. Oh, sorry, pick the wrong one. So we go arc fixed, center line radius. So we go fixed arc, center radius and ends. Arc fixed, center radius arc, same as. Sorry, we're talking about, it was a survey pickup, that one. So we're looking at a fixed arc, 3 points. I'm going to pick a point here. And a point there. And a point at the end. So we've got the thickness of the arc. We now want to be able to then float through these known points. So it's just a matter of going insert. We go down to arc floating. We're going to do from the end of the previous part. We want to pass through a point, and the point's just simply that little construction point there, and it puts in the arc. So we're just going to do a few of these. So we're just going to copy and paste. Again, activate, pick the point, and go set. So now I'm getting down towards this part here where I need to be able to tie into the existing or a fixed option. So I go insert. Again, I'm going to pick up an arc, center and radius, I draped it. It's been draped, so it's got to be back to an arc. 3 points again. So I'm going to pick a point on here, pick a point on there, and a point on there. I need to have my offset here. So again, it's going to be -3 offset. Get set. So similar to our row designs and all the things we've been doing before, we've got a fixed part here, a solve part there. So we need to be able to put something in between here for the final one. So that's going to be a free arc. So we're just going to use the arc free from end. Let's go set. So it's going to go from the previous arc here and then tangential to the extended existing arc or fixed arc. So again, we go back onto the floating, copy, and simply just go paste, turn on. We can pick the points. So we can pick the points and start to make our way around through here, just putting in floating curves and doing very much a free-form design. And the last one. Just like we tied in with our curve before, we need now to tie in with to the building alignment. Again, we can go insert. It doesn't have to be a computator. We can just do a simple fixed line. The building's not going to move. We can use the same as button. And go set. So again, to join those two, we just simply just say I want to insert, and again I want another free arc. I want to go from the end. Here I'm going from the end of the previous one to the building, but I could have changed that to next, and it would have turned around and gone to the end of the building. Not much of a difference there. That's our free-form design. So basically using the simple options, starting with a fixed element, floating through the trees, through some critical points, referencing or being offset from a fixed part over here again, and then floating, and then finally finishing up with a free arc between the two solved parts here. So to go through the process of in the short amount of time we've had, just to give you a bit of an idea of the parts of the fixed and floating, and don't be too worried about the fact that we've gone into the computators. It's basically the same process. It's just that you're picking and referencing things rather than just putting in XY points and bearings. On the Superalignment toolbar, there's a question mark for help at the end here. This does give you a bit of an explanation as a reinforcement on what fixed and floating is all about. The fact they fixed as a combination of bearings and coordinates, and you also got lines and straights and a bit more information about floating lines and arcs. You can also read in through this read button here. You can read in the majority of the parts that are available. Hasn't been updated for a little while, but the majority of them are there. These are actual alignment strings that you can edit. So in that case there, I've looked at the a fixed directional line. Anything with the word comp in front of it means computator. So in this case here, you might look at some of the more difficult ones, and so you can just bring up your editor and you can pick this string here. And I can look at the part, I go in the horizontal. Some have vertical geometry in them too, so you can profile them, have a look at what they've got in vertical. So in the fixed line, it's a computator because it's got a little asterisk next to it. So here I'm just looking at the a fixed line, and one of the choices was point drop reference. So it actually creates a point and then drops it onto your center line. So in that case here, I can my reference string is this string here, and the fixed point is the intersection of these two lines here, and they could be two design lines, it could be two existing survey lines. Has a nice little feature here where it allows you to say the point you created, is it the start of your alignment string or is it the end of your alignment string? At the moment it's the end. If I change that to start and go set, then the changes turn around and go the other way. So again, just another alignment string that you can edit. There's also a regression, which you can, this is a little bit exaggerated, but this could be survey pickup points, and you can then get the fixed line to do a regression between those 2 points. This one just takes the string. This one here has a start point, and then does the best fit between those two geometries. You can have a look at that. Floating and free lines, again, you've got these sorts of options here. You just have to edit the alignment string and have a bit of a look at what it actually does. So this one here, for instance, you can edit the alignment string, and you can see that's just a combination of a fixed circle and on a floating line. So again, with the floating line, it actually allows you to have the inbuilt transition length. So I made it put the transition length in here for the lines. So a lot of the arcs have that option as well. So again, you've got the fixed arcs, combinations, anything with comp in front of it refers to a computator. You've got free arcs, we did quite a few of those, so there wouldn't be any of those that are different. The only extra one here you'll have would be where we pass through a known point. With this computator one, it actually uses the end of the string as the point. Floating arcs, transitions and spirals, so anyone that's interested in the free arc-to-arc transitional spirals, back-to-back ones, just edit these alignment strings here, and they'll give you an idea of what parts that you would need, obviously, to create a solution. There's a couple of computator ones there as well. Again, not all of them, but a fair majority. There are also, in this help option, there's some show solutions. So you can go next, and it will actually then allow you to read in some information. So if you weren't too sure about what sort of transitional spirals or that you would need between different elements, you can read this one in. So if I read that in, you'll see that it's actually got the element string, fixed one, a floating arc, okay, with transitions in there and so forth, and also fixed arcs and free transitions between the two. So you can have a look at those alignment strings and edit them and see which part may suit you. Again, they get a little more complicated, some traffic islands, simple cul-de-sacs. Nowadays they're probably just taken over by the fixed compound that we did before. I've got some rail jobs there, so you can see how to do some loops and sidings. More complicated intersection, or interchange. So in that case there, you can read that in and edit some of these alignment strings, get a bit of an idea of what may or may not be able to be done. So again, we've got the same sort of thing, got a roundabout here, so we can read that in. This is not a component, and we'll look at some of the components at another stage, because the components just use all these element type methods. So if you are going to look at the components, placing of automatic cul-de-sacs and all that sort of thing, then you will have to be skilled up on fixed and floating, which is by attending this webinar and being able to see the video. Hopefully that will be the case. So okay, so here we have the same sort of things we showed before, the island referencing alignment strings. Again, we've got curb returns here, so you can actually edit these alignments and have a bit of a look and see what they actually comprise. And most of them you'll see will just be either referencing a segment or a straight, and then possibly putting in just a free arc, or possibly a combination of a couple of floating with a free arc at the end, linking back to the fixed road. So there's quite a lot of options there for you, but at least you have that inbuilt help to be able to get you more familiar with fixed and floating. Just like to say thank you very much. Are there any questions?
Thanks, Peter. We've just got time to fit in a couple of questions. James in Brisbane just wanted to clarify along the way, and it may have been covered since, but does each floating element turn into a fixed element?
Basically, it turns into an actual solved part. So you may have mentioned, as soon as I mentioned a solved part versus a fixed part. So yes, once that any part of the alignment string is solved, for all intents and purposes, it can then be used as a fixed entry for any subsequent parts.
Sure, thanks. And Ralph from Sydney asks, can you construct an alignment from both ends and meet in the middle?
Well, basically, yes. That's sort of what we started to do here, even though I did go in the order. I could have actually put in the fixed tie in here. I could have put in all my fixed tie-ins, a bit like I did in the vertical. And fixed tie in here. And obviously, when you then went set, the connection between the two would say error, but at least you'd be able to put in those control points and then come back in and say, well, okay, what do I need to fix this up? In horizontal, it may be a combination of floating and free elements. In vertical, it may be fixed grade lines or parabolas.
Thank you, Peter, and thanks to our audience for your great questions. Sorry if we couldn't get to yours live today, but we'll answer you later by email. The recording of this webinar will be available in coming days through our website and our YouTube channel. Our next training webinar will be Culvert Design with Upstream Storage on the 14th of September. We'll also be continuing our Industry Solutions webinar series from next week, so do see our website for details of those. We'll keep updating it with many more topics in coming weeks, and also continue to keep you posted through email and social media. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.